Hey guys, it's Mr. Chandler here again to give you a little bonus video before tomorrow's test, before the free response portion. So I thought I want to do a little short video with you here just to go over one of the things that you're going to see tomorrow, and that is an acceleration versus time graph. So let's just recap real fast. We've already talked about how we have position versus time graphs, and we said that the slope here equals velocity, and we can go make a velocity time graph, kind of go from this graph to this graph, right? And then we say this velocity time graph, the slope here is the velocity here, so we can have a velocity time graph, and then the slope here of a velocity time graph goes to acceleration. And we can have an acceleration time graph. In this case, it would be on the x-axis because it's 0. So 0 acceleration. So we're going to have this step 1, step 2, step 3 type of situation where we go from position time to velocity time to acceleration time. Tomorrow on the test, you're going to see it's just an acceleration time. There are 2 questions tomorrow, and the first one, which is the harder one, is going to give you an acceleration versus time graph. And I'm just going to make up something here. So tomorrow we're going to get this graph, and we want to go from here, and we want to work our way backwards towards the velocity time graph that we already are familiar with. So let's take a look and see what we got. I'm just going to make something up here. Let's say it has constant acceleration here. Let's say that's 1. And then let's say we go down to 0, and then maybe we go back up, and then we go down, and we go to 0 or below 1, and like that. So it's -1 here. Let's say this is 5 seconds, 10 seconds, 15 seconds. That's 20 seconds, 25 seconds. All right, so say we get a graph like this. So we have a positive acceleration for 1 second. Then we have 0 acceleration for 5 seconds. Then we have 0 acceleration for 5 seconds. Back to +1 for 5, 0 for 5, and then we're at -1 for 5 seconds. So how would we draw the velocity time graph based on the acceleration time graph? So kind of make a miniature one above it here. I'll just go right here. Make this velocity time. Make this kind of take this information and transform it into the velocity time graph. So let's number this. Let's go 5, 10, 15, 20, go a little longer, 25. This is kind of sloppy, but that's okay. It's a quick little video. And then we'll have our velocity go up to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Just fit in there. Okay. So what happens? Well, let's assume we start off at zero initial velocity. So we start off at the origin, and we have a +1 acceleration for 5 seconds. Now we already said before, right? We remember that the slope of velocity time graph is acceleration. So if we're given the acceleration is 1, then that means the slope of this line must be 1 for, in this case, it's for 5 seconds. So we go up 1 over 1, up 1 over 1, up 1 over 1. We do that 5 times for 5 seconds. So we should end up at about here, at 5. The slope equals 1 because that's what our acceleration was. And then we have no slope for 5 seconds. So no slope, that means no acceleration. Now, key point here, we are still moving. Just because the acceleration graph shows us at 0 acceleration doesn't mean we stopped. We haven't stopped. We're still going. We're just moving at a constant velocity now. We're no longer accelerating. We are moving in the positive direction. And then we're going to accelerate again, and we're going to have an additional, we're going to speed up some more. Another positive acceleration, again at 1 for 5 more seconds. So we go up 1 over 1, up 1 over 1, up 1 over 1 for 5 more seconds. So we should end up at 10, something like that. And then we go back to 0 acceleration for 5 seconds. And then we go actually a -1, so we slow down a little bit for 5 more seconds back down here. So this is what our graph would look like based on our acceleration. It looks pretty different, right? Key things to note here is that we went in the positive direction the entire time. We never turned around. We have positive velocity, positive direction, the whole time. Even here, just because the graph is going in a downward angle like this doesn't mean we're going in a negative direction. It just means that we're slowing down, or a velocity are getting from large 10, 9, 8, 7 to smaller numbers. So we're slowing down, but they're still positive numbers, so we're still going in a positive direction. So with this information, I might ask you, what is the displacement at a certain time, and you could find out, make your little rectangles and triangles, and you could find the displacement at whatever time I asked you for. I might ask you what's the speed at a certain point, and you find the spot on the graph, and you can tell me what the velocity was. So you can get position, displacement, you can get velocity. Of course, you have acceleration. All these sorts of questions you might see tomorrow. So hopefully that was helpful to you on how we can build that graph based on the acceleration time graph. So if you have any questions, don't forget, always message me on Remind or email me if you have any concerns or questions. And I will see you guys tomorrow, and good luck.